Hey there, I'm Dominic St-Pierre, and you're listening to Go Podcast. So this will be a special episode today because for the first time I'm getting a guest today. So Matt Boyle, thank you very much for accepting this invitation.
No worries. Thank you so much for having me. I'm a big fan, so it's great to be here.
Nice, nice. So yeah, we will talk about debugging in general today about and Go and whatnot. But if you want to give a little bit description about yourself. What's your experience with Go, and why have you choose debugging for your course? That's interesting to me.
Cool. Yeah. So again, thanks for having me. My name is Matt Boyle. By day, I'm an engineering manager at Cloudflare. I run two teams that mainly focus on developer tooling and developer productivity, and we use Go for pretty much everything we do. I'm a big fan of it. Um, by I'd say by night, but it's really by morning. I think we were both just talking about how we're early birds, but by morning I tend to do quite a lot of extra bits and pieces in the Go community. So I wrote a book last year, which domain driven design with Go, which was actually a bestseller on Amazon, which is something I'm really proud of. I run a Go community on Twitter, which is the biggest Go community on Twitter, which is I think we've got about 4,100 members now, which again is really cool. It's super friendly, so check that out. And I'm currently working on a course on debugging. The reason I picked debugging as a course is because I feel like it's never taught. At least I was never taught explicitly. I learned a lot about debugging. To be honest, I would say in the trenches when things went wrong and I had to figure out why they went wrong. I would either partner with someone who was more experienced than me, or I'd figure things out as I went through tutorials or videos. And I think a lot of people could benefit from explicitly being shown how to use even just the basics of some of the tools, such as like the debugger or strategies for logging, or how to use Prometheus to capture some metrics about your application. So I figured it was a really good place to start with a course. Hopefully, it can add some value. I don't see a whole bunch of discussion or courses around it, and I managed to stir up a bit of a storm on Go Twitter when I asked folks if they use the debugger, because everyone I work with uses it, but it turns out that it's not as widely used as I thought it was, and which was an interesting lesson for me.
Yeah. Yeah. I remember that tweet. This is what drive me to ask you to join this, because yes, I think, like you said, it's not really talked much. Yeah. Before we go and unwrap a lot of this, I'm curious. And congrats for the book, by the way. It's wow, it's a super achievement. And first of all, did you find it hard to write a book? Actually, what was your experience? I'm just curious here.
Yeah, I think writing a book is certainly challenging. I think the hardest bit is that it's a marathon, not a sprint. Like when you commit to writing a book, especially something so long form, is you've got to kind of commit your free time for a year. It basically took me a year from idea to having it published.
Yeah.
And that meant sort of dedicating weekends and evenings and mornings to writing it. And then, you send it off and you get some feedback and you have to make changes. And so it's just a really tough process. So I think the hardest bit is just kind of having that continuity of focus on a single thing. And I think it was a good experience for me from that perspective, because the achievement of getting it published felt huge, just because I knew that I'd worked on it for so long. And I think sticking with one thing for a long time isn't something I've traditionally been very good at. So that was pretty good. And I think that was the hardest bit more than anything.
Right. Yeah. Nice. So yes. So we will have some links on the show note, obviously, and then your current course is pre-launching. So I mean, if people are interested, they will be able to follow some links there. So that's nice. So yeah, returning to that tweet, I was a little bit surprised as well to see the result. And to be frank, I haven't seen the last result. I only saw when I voted myself. When I voted myself, I think it was something like, around 70% that people were using debugger, and somewhere like 30% that weren't. So can you talk a little bit about the last result that you got?
Yeah, so I think by the time the poll closed, around 800 to 900 people have voted, and it actually skewed a little bit downwards to what you saw. So I think around I'm going to get the maths wrong here, but something like 60% said they used it regularly. Something around 20% said they didn't use it. And then around 20% said that they don't know how to use it, which I think was an interesting distinction. So, I got a lot of respect for folks who don't use it if they've got experience and they've got a workflow that works for them. It's a tool. If you don't want to use it, that's completely reasonable. Maybe you've got another workflow that works great. But I think the people that I'm super interested in is that 20% that don't know how. Even if I taught those 20% or those 20% learned how to use a debugger and then they ended up going into the no pile, I think that's great. But I think it's really important that everybody has enough experience and awareness of it that they can make that choice themselves.
Yeah. It's very interesting because, well, I'm coming from a .NET world in my early career, so let's say the first 10 years of my career. And, in the .NET world and Java, the debugger is part of your day-to-day. It's something that it's just there. It's in the tooling. And this is a de facto way of, I would say, even write your software and your systems. When I switched, I keep saying I don't like people when they are saying that word, but when I started to program in Go, I will admit that I've kind of missed the the Visual Studio debugger and whatnot. Call it what you want. I kind of missed that, but it soon becomes something that I was fine not having, because to be frank, in 2014, maybe the tooling was not there as it is today. And to be completely frank, I'm probably part of those 20% ish, whatever, that don't really know how to do that, because I haven't used Delve or anything like that with Go, to be frank. And I use pprof. I don't even know if it counts in the topic of debugging, but yes. So what would you tell to someone today that would want to start experiencing what it is to debug, or at least to start debug in Go? What should they do?
Yeah, and for what it's worth, I think pprof definitely counts as debugging. I do have a module on my course around using pprof, because I think performance issues are still things that need to be debugged to figure out what's going on. I actually have a very similar journey to yourself, I think. So, I started out writing Java. I did a computer science degree. We learned it all in Java. And at no point during my degree did anybody show me how to use the debugger. It just wasn't covered as a topic. So I kind of entered the workforce not really knowing how to use the debugger either, and also kind of fearing it, I think. It seemed complicated, right? And I think it certainly was in some languages, because one of my first jobs was using PHP and Laravel. And to this day, I've still never successfully set up Xdebug properly with PHP. I got it working a few times, but I never managed to get it working like all the time. So I definitely fell backwards to I'm going to log stuff to figure out the state of the world, because it was the only way I knew how. And I still do this often in JavaScript too, especially working on front-end stuff. Again, I've got the debugger set up at times, but it's got this sort of overhead to getting it set up, and usually by the time I've got it set up, I could have just put some log lines in and figured out what I wanted to do, or wrote some unit tests that helped me figure out what I was trying to do too. So I think I definitely understand people's point of views, and I definitely understand people's hesitation to get going with it. I think one of the really nice things about Go specifically is that the debugger has very low barrier to entry. And I think if someone sits and shows you how to do it, which, as I say, I will in my course for 5-10 minutes, I think you'll realize like how fast it can be to get stuck into code and to use that as a viable way of debugging, rather than adding log lines and then having to rerun the tests. Rerun the program or the test, depending on how you're doing it. I think the debugger really comes into its own when you're trying to, debug a test. Lots of people will say, use instead of using a debugger, write a test, but tests are code too, and you can still have flaws in your logic in your tests, and using the debugger there can be a really powerful way to figure out where you might have gone wrong. And the other thing is, if you're working in a bigger company and you have to take ownership of code that you've never seen before, being able to step through all the workflows very, very slowly and just kind of figure out what's happening and when, and basically just pausing the program is so powerful. So I think I guess to summarize, the barrier to entry for the debugger is very low with Go, and I think if you haven't sort of given it a try recently, it's definitely worth Just spending 15, 20 minutes, just seeing how quickly it is to do. And then I think you may be a convert, maybe not.
Yeah, that's good. I mean, well, you said it. You said it straight to the point. So to me, the path I chose when I started writing Go was mainly to make sure that I would have some tests to back me, and maybe maybe that's true what you're saying. Maybe when you are inheriting a huge code base, it might be. It might be a good tool to have, but yeah, let me do the devil advocate in here and say that, and well, yes, I think the test suite should probably be the first step to understand a code base, in my opinion. So when you are inheriting something that you don't really know, and let's say that there's a couple of very very complicated things. Could be a package, could be multiple functions, whatever. Should the tests not be the right place to understand the test and maybe hopefully some documentation?
Yeah, totally. And I think that's a super reasonable comment. And I think they should be seen as partners and not opposites. I think the way I would counter that is, I'm sure all of us have worked on large code bases that don't have the test coverage that we'd expect. And so adding it will be something that should be a great first task for you, perhaps, but it also doesn't necessarily mean that you can do that without understanding it, which is usually where the debugger will come into play. Secondly, as I mentioned, sometimes test logic can be flawed too. I've certainly seen issues where customers have raised issues and they've said, oh, this isn't working as I'd expect, and it doesn't work as per the documentation. And when you actually look at the test is wrong. The testers assume the wrong thing. So, tests are fallible too. They can fail if humans have misunderstood what the requirements were, and requirements change and the test might fail. And you may want to dig in a little bit to figure out why that is. The debugger is super helpful there too.
Yeah. Oh yeah, go ahead.
I was going to say the final thing is test philosophy, right? Like lots of people have very different views on testing. Some people write lots of unit tests and very few end-to-end tests. Some people write lots of end-to-end tests and very few unit tests. And depending on how you decide to scope those, maybe you do it like from a business perspective, like this is what the customer should see, versus like very technical deep dives into how the software should operate. It might determine how easy it is for you to figure out whether the test can teach you what you need to know about the system to be productive on it. Because, for example, say the test is, as a user, given I use an Amex, I should get charged a 3% fee. Like, that's a really good test, in my opinion. It explains user outcomes and behavior. But what it doesn't necessarily tell you, without maybe digging into how the test is written, or maybe even jumping into the code a little bit, like, how is that calculated? Like, is that got third-party integration in it? Who's that with? How long does it take for that HTTP call to come back to me? What does a response body look like? Those things might not necessarily be explicitly covered in the test, but as someone who's going to be taking ownership of the system, like that's very interesting to me. So being able to debug through the code in that test will help me learn an awful lot.
Yeah, that's interesting. Very, very interesting. So would you say that you are using the debugger, mostly on your local development, or it's also a tool that you do appreciate on production system, for example?
Yeah, I tend to only use it locally, to be honest. There is a way to run the Delve debugger in production, and there's also ways to get like a dump of a request so you can actually debug after the fact as well. I'll be honest, I don't do that too much. I tend to use debugging locally more than anything, and I tend to lean more on other methods for debugging when I start to reach customers in production. So typically, hopefully by the time I get to production, I've got great test coverage, which covers a lot of what I care about. But then once I get to production, I've got business metrics. So I'm using things like Prometheus, and I'm using things like logs and things like that and tracing to be able to figure out like where the problem and bottlenecks might be in production, because we can do it on a much larger set of data and we can aggregate that. So I tend to use those when I get close to production. And then something you mentioned previously is pprof. That's really useful in production as well. So most of the services at Cloudflare that our team runs, we have this debug endpoint, and if you hit it, it'll take a dump of the profile information at the time, and then we can use that to do some local analysis to figure out where bottlenecks might be. So I tend to use debugging locally to figure out defects in thinking or system behavior. And then when we get to production, hopefully the things we're mostly focused on is performance and latency perhaps. And then I can use those other tools to figure that out.
Yeah, interesting. So are you mostly interested in memory consumption, or it's more like CPU bound things at Cloudflare?
Yeah, in our team we've had issues with both, to be honest. We tend to have less issues with CPU bound workloads, mostly just, to be honest, because we probably over provision them. We haven't had too much pressure to sort of optimize the CPU at this point, so we tend to just over provision and we're pretty good. Memory is something that's a little bit more, I wouldn't say it's more problematic, but we have some like workloads that are a little bit more bursty. So you might think you've got your numbers right for memory in Kubernetes, and then all of a sudden your pod crashes, or you're seeing it being throttled. Yeah, so occasionally you'll see like you're being throttled because you're using too much of it. So that tends to be more of a problem. And sometimes it's not always entirely obvious to us from the outset where that memory is being used. And that's when we'll probably look at metrics to see, if there's anything interesting there, because we obviously have, if you use Prometheus native library, it gives you CPU and memory usage out of the box, which is very, very helpful. And if we still can't figure it out, then we'll probably pull a profile and take a look and see where we're spending the time and where that memory is being used. Which has been really helpful for us to figure out some pretty nasty issues we've had in either our code or potentially in libraries as well that were maybe not releasing memory as much as we'd hoped.
Yeah, that's what I've been using pprof myself. So yeah. So let's return to in the shoes of a Go programmer. Let's say that you start on a new assignment. You inherit this new code base next Monday, and so. What is your process actually? So do you run it with the debugger, and what do you do with this debugger? Is it mostly like breakpoints? Is it mostly like to investigate local variables, some values, just to have an understanding of what is the flow of a typical process is doing? So how are you using that?
Yeah, it's a great question. I have a shout out for another little project that I've been doing as well. So in the next couple of weeks, John Calhoun and I have been doing some code reviews that we're going to publish for free somewhere on the internet. We haven't figured out where to publish them yet. But effectively, we've asked people to send in code, and then John and I are just pairing live to kind of look through it, give some feedback, and talk about how we approach the project. So that might be helpful for some of this. We don't use the debugger in it. We actually just walk through it and talk about how we approach a project we've never seen. So that'll be somewhat helpful. But to kind of answer the question directly, especially if this was at work and a bigger project, I would do exactly as you described. Like, assuming it's a web project, the very first thing I would do is I would just pull it and I would look at the README, if it has one. Sometimes they don't, and understand exactly what it's being used for and how I should be able to run it, and if there's any dependencies I need to bring up. So typically I'll take a quick look to see if it's got a Docker Compose file, because that's very helpful. After that, I'll probably jump into main.go and see how it's bootstrapped. The really nice thing about Go is that all programs originate in main.go, so it's a really great place to start if you're trying to figure out when I press run, what's actually going to happen. You can follow it from there, and if it all looks good and it seems reasonable to me, I probably won't set a breakpoint in main.go, and I'll probably head to the router, the serve mux, and maybe set some breakpoints on some of the endpoints, and then I'll try and construct some requests to those endpoints to step through and figure out when I hit the endpoint, it'll pause there, and I can just step through it one by one and figure out what actually happens on all those endpoints. Once I roughly understand how it's working, how it's running, and how to start it, that's actually the first time I would personally jump into the tests, which may be a little bit against the grain of what some other people recommend. The reason I like to do it like that is, at least the way I write tests, or the way I sort of read tests, is I'm trying to understand business behavior, right, and what happens from an outcome perspective for customers. So I tend to just like to have a very small overview of how the system's constructed and started before I start looking at the business outcomes, and then I can usually click together in my head exactly how those two things fit together after I've done those two things.
Great. So what is the what does the output look like? Because yeah, like I was saying, I personally never used it, so I don't even know what it looks like. Is it a GUI based thing? Is it something, where are you seeing those values? Is it like on the terminal? Is it like GDB, like where you do enter some commands and you manually walked into the code, or how is it working?
Yeah. I have massive respect for engineers who use like Vim and some of the tools out there. I'm not one of those engineers. I am very IDE dependent. And to be honest, I think IntelliJ should probably be giving me a commission at this point for how many people I've tried to sell on Goland, because I just think it's great. I mean, it's a paid for tool. I think it costs like $150 a year. But the productivity I personally get out of it once kind of I figured out how to use it has been immense. I know there's a lot of people who love VS Code as well, and I think you can achieve the same things. But every time I've tried VS Code, there's just been a couple of things that didn't quite work, for me at least, as well as Golang. So I tend to go there. So my first bit of advice is, if you're a beginner just starting out, like, there's a free trial of Golang. Like, give it a go for a couple of weeks and see if it's for you, and then you can try and convince your boss to buy you it, or you can fall back to VS Code. But the really nice thing about Golang is it all just works out of the box. So typically when I start a debugger, all I'm doing is I'm clicking in the gutter of the program, which will set a little red dot. I'll click the bug icon in the top right, and that's it. That's all the configuration I need to do to set up the debugger in Golang. What will happen then is I'll make a HTTP request using Postman, and that will issue the request, and it will hit the debug breakpoint, at which point Golang will come back to the foreground. At the bottom of Golang, it will then show you a bunch of useful commands and information. So there's like a little kind of terminal GUI style thing that includes the current values of things that might be interesting to you. So it'll contain the request and the response, and maybe if there's some headers that you've assigned to variables, you'll see them there. So you can inspect the values of them at points in time. Mm-hmm. You can then step over or step into functions, or press play, and it'll just continue the whole function through to the end or to the next breakpoint. So typically what I'll do is pause there and just keep pressing the step over and watch as the values change, and the things that I'm interested in, see what happens to them. And you can also, that thing that I right-clicked in the gutter, you can also right-click that again and put set condition. And you can set conditional breakpoints too. So maybe we're seeing a very specific issue that a customer raises, and it's like, well, if someone's name, if someone's email address has this special character in it, it's causing us an issue. So what you can do is you can set a conditional breakpoint and leave the program running, and you can try a few requests without that special character, and you can see them go through completely without pausing the program. And then as soon as it evaluates the value to have the thing that you set the conditional breakpoint to, it'll then hit the debug breakpoint, and you can step through from there too. So there's some really nice things that you can achieve, and it's all GUI based, especially in Golang. You can set it up to VS Code to be the same. You just have to download a couple of things. And being able to inspect the values like that and just see what's happening at a point in time is so incredibly helpful, I think.
Yeah. I think I can hear the 30% people that are not using debugger for this email example and scream something like, well, this should probably be a test, though. I mean, since there's a problem with the system with a certain situation or scenario, this should probably be a test, no?
I think there's two answers to this, right? There is 100% the purist point of view, like there should be a test, and I would agree with that there should be a test for this too. But depending on the type of code you're inheriting, whether it's got some technical debt, or maybe the strategy for testing is a little bit different in its application, or maybe you just don't have enough experience to add the end-to-end test right now. Maybe you need to wait for someone to become free who can show you how to do it. Like, the debugger is a way you can unblock yourself, right? And you can step through the system, understand it, and then you can maybe go to someone afterwards with a little bit more experience, and they can help you add the test to cover that specific scenario. Not every piece of Go code I've ever worked with has been particularly granular and well structured. And I can hear people shouting at me, "Well, you should fix it. That's tech debt," and it's like, that's 100% true. But businesses choose to take on tech debt all the time and to continue to work with it. And so, in an ideal world, yeah, we should have tests for everything. We should cover everything with tests, and we should be able to add tests very, very quickly to yield the outcomes we want. But in a world that's a bit more pragmatic, being able to unblock yourself and use a tool that's available to you to be able to figure something out like very, very quickly, and to help you understand a system maybe you haven't worked too closely on before, is really, really powerful. And I don't think it should be discounted as an approach just because it doesn't match the purist view of what we should be doing.
Yeah, yeah, totally. I mean, it's so what about, you know, you're debugging an endpoint, like you said, and you have a breakpoint in there. What happens if that particular function is calling a Go routine, for example? You know, is it capable of handling multi concurrent code? And let's say you have also a breakpoint on the function that is running concurrently. So what happened in that case?
Yeah, I added a module to my course specifically on debugging concurrent code because it's hard. And there's some really nice things you can do to make it a tiny bit easier. But yes, the debugger is capable of debugging concurrent code. One thing that's very difficult is figuring out which Go routine is the one you want to look at and which is the one you care about. Because Go just kind of assigns, they're not random. It makes sense to the Go runtime, what they're called, but to a human, it's maybe not as obvious. So one thing you can do is you can annotate Go routines. So you can put a little bit of logic around it. And I think it's actually from the pprof package, if I remember correctly. And you could say things like, call this Go routine Matt's main Go routine, and call this one Matt's routine 2. And then when you run the debugger, it has a stack of all the different Go routines. And because you've labeled it, you can quickly identify the one you care about. And then all the things I've talked about previously about sort of interrogating the values and seeing what they are at a point in time, you can do that with these Go routines that you've labeled. So just giving yourself some extra meta information to figure out which one's which is really, really useful. It's very easy to do. And it makes debugging concurrent code, I wouldn't say great, but it makes it tolerable. Tolerable is the word I'm going to use.
Yeah, that's impressive. Yeah, I can see myself maybe wanting to try that. I don't know. It seems to be yeah. I've been you know, I will not lie. I've been using a lot of print debugging, and you know, sometimes it's fine. Sometimes it's a little bit tedious, but yeah, I tend to I tend to rely on tests. But I can understand your point. You know, to return to my early careers in .NET, I was mainly using breakpoints, and this was something I was thinking about while preparing for this interview. I was asking myself, why it's strange that you can use a debugger for 10 years and all of a sudden you don't really miss it. And I started to ask myself, what I was using exactly, and what makes me, makes me today not really needed that or need that. And like I said, I was mainly using breakpoints. I was never really a huge inspect variable or things like that, and see value changes and whatnot. So I think that with experience, it at some point you kind of do the job of the step in step out debugging, mainly in your head, mostly quickly, I think, and I'm not saying that it would not be useful. I'm just saying that I'm wondering if at some point in a career you have seen enough code that it might be. It's almost the same. I think in my mind, when I look at some code, when I read new code, I kind of do a little bit like what the debugger is doing. So I'm not sure there is a question in everything that I'm just saying, but this is mainly why I think I'm not personally missing the debugger. But the thing that you explained so far, it seems to be very similar to what Visual Studio is doing in the .NET world, and I can really see the values, but I think I'm not missing it still.
Yeah, and that totally makes sense. I think one thing I'll call out is I definitely debug by logging too, and there's a whole module in my course that I've called debugging by eye, which just kind of talks through exactly what you said. Like, once you've seen a lot of code, you do start to spot mistakes faster and easier. And I think that's totally fine too. One thing that I did notice in that thread, and also from subsequent discussions, is I don't think there's any correlation between how much experience you have and whether you're using a debugger. I saw people who I really respect who've got tons of experience saying they don't need it and they don't use it. I saw people who I also really respect and have got way more experience than me saying they did. And the greatest example I can give, and we can link this in the show notes too, is there's an interview that John Carmack did recently. Most people probably know who John Carmack is, but if not, he created Doom, and honestly, it's probably reasonable to call him like the father of modern gaming. He made Oculus. Like, he's an incredibly impressive individual, and many people will say he's like the greatest of all time when it comes to like development. He uses a debugger, and there's a whole interview where he talks about why he uses it and how he finds it very, very useful for understanding code. So if it's good enough for John Carmack, it's good enough for me. That's what I say.
Yeah, I saw this interview. I think it was with Lex, and I'm forgetting his last
Friedman. Yeah.
Yeah. Yeah, totally. I mean, but yes, I mean, this is very much. Do you think that the tooling has changed? Was it good like 6-7 years ago? I think you started Go in like 2018 or something like that. So was it good at that point, or it's now really smooth and whatnot?
Yeah, so I think when I first started out, I do remember that VS Code potentially didn't have great support for this, and I do wonder if there's any correlation between that and people's views on it. Because I know that a lot of people use VS Code because they don't want to pay for Golang, which I think is super reasonable. A lot of people can't pay for Golang, right? So it makes sense to use like the free tooling out there. But you needed a bunch of plugins and stuff set up to get the debugger working, at least at that point in time. And it was a pain to get going. So I do wonder if people thought, well, this is the same as it was in PHP. It's too hard. I just don't want to figure it out. Like, I'll just stick to what I know. I'll stick to logging and other stuff. I'll write tests and I'll figure it all out that way, which again is super reasonable. And if you've got a fast workflow doing that way, like, more power to you. But it's worked in Golang very, very well since the beginning, as far as I can remember. Like, if there really is zero setup, you just click in the gutter and then press the bug icon and it works. So I think, especially people where Go is not their first language, maybe they've had experience in other languages where it's really, really hard to debug. We had a similar conversation at Cloudflare recently, and some folks were saying there that it was quite hard to get the debugger to work correctly with Rust. And a lot of those folks saying they've had to discover alternative ways to do it because of that. So I just wonder if there's also this stigma that comes with the debugger that people have brought from other languages, where if you take Go on its own, it does a lot of things a lot better than those other languages. That's why I love it. Like, it's super easy to containerize, super easy to debug. It's very, very fast. I also wonder if its speed is some of the reason that folks just stick with logging, because you really can throw a log in there and hit the play button and it will run in a few seconds, right? Whereas some of the other languages you might be working in, it can take a little bit of a while to recompile it or do whatever you need to do to get that log line to spit out. So there's no bad options here. Like, it's just great that there's options, there's tools, and folks can try all of them and see what works best for their workflow. But as long as my main thing is, I just want everyone to have the experience to have an opinion, and if your opinion is that it's a waste of time, then more power to you.
Yeah, totally. I mean, this sounds interesting. I think this idea is worth digging a little bit. Yeah, maybe some maybe a last question of mine. So, would you have any tip or trick for distributed systems? So let's say and I'm talking more about tracing this time, maybe not so much debugging, but would you have any tips for someone that is working on a distributed system? So what should they do to have a good tracing system, for example?
Yeah, I think you've kind of called out my advice would be just get some tracing in place. Like, it's very, very valuable to be able to see a request from the point of issue all the way through to whatever subsystem it might be hitting. This can be really, really challenging if you are using something like a message queue or message broker in the middle like Kafka. Like, propagating traces through those things can be particularly challenging, but it's worth the time investment. And once you kind of get that stuff up and running, you can actually start to embed logs in the traces, and you can see average response time on endpoints. And it's very, very useful for helping you debug distributed systems. The other thing I would say, though, is, if you are having to spend a ton of time thinking about like entire request flows through your application, maybe it's time to consider separation of concerns as well, and make sure you're kind of thinking about your system, right? So in Cloudflare, we have like domain-based teams. We certainly have to call other systems to get certain bits of information. But typically that we see that as a boundary, right? Like we may have to work with that team if there is particular latency in a particular situation or endpoint or something like that. But we really try and think about those teams as third-party companies, right? In the same way that you might integrate with Stripe, and you might call Stripe, and you might care about how long it takes for Stripe to respond to you to charge a customer. But unless something was going extremely wrong, like you wouldn't necessarily raise a support ticket with Stripe because their system wasn't behaving how you want it to or expected it to. You kind of work with them in a contract-based way, right? I'm going to call Stripe, they're going to give me this response given this request. We try and treat other teams at Cloudflare like that, and I think that's a pretty good pattern and idea for scaling out a business, so that you don't have to necessarily have tons of interactions with those teams beyond they publish this contract, and we're going to work against that to make sure that we can continue to be productive on our own path without having to wait too much for them to do stuff for us. And we use gRPC in a big way to do this. We publish the protobuf, and then we can work against that, which is pretty powerful.
Sounds very interesting, to be frank. There's probably a lot of engineering at Cloudflare that would be interesting for me to see. I haven't been part of a big software company like that, to be frank, and I think this is something that is missing in my resume. So do you have any closing thoughts? I don't know. Again, I tend to believe that the listeners are, well, I don't really know exactly their experience level, but would you have any closing thoughts? Some things that you want them to know. Obviously, we will have some links to your new course, your book as well, so they can obviously reach you on Twitter. But do you have any recommendation or any closing thoughts?
I can't think of any top of mind. I think I'd love to see more folks in the Go community on Twitter. It's open to everybody. I want it to be as friendly as possible. So if you're interested in just having sort of discussions about Go that are as friendly as can be, from beginner to expert, like please join us. It'd be good to see you there. We have meetups every month that are completely free. We had one last night, which was a lot of fun. So it's fully remote. So we'd love to see a bunch of you there. And I'm looking forward to the Go 122 release. I'm sure a lot of other folks listening are too. Maybe it'll even be out by the time this is published. So I've been spending some time reading the release notes there. There's some pretty cool changes in there. So I guess my leaving thought would be make sure you check those out and get ahead of it, because there's some nice changes in there that are going to make hopefully make your program faster, and potentially going to lead to less bugs in your code. So maybe you'll need less of the debugger thanks to some of the changes, especially the for loop change there.
Yeah. Oh yeah, totally. This release seems to be very nice. Cool, Matt. So thank you very much for joining today, and again, I mean, hopefully that gave some good information to people. Again, like you said, I don't think it's a topic that is talked much in the Go community, and yes, if you want to test the debugging, then at least you have a good course that is coming very soon, and you have gotten some great information. So thank you very much for this.
No worries. Thanks so much. Thanks for having me.
All right. See you next week.